Okay, folks, we are in section 2.1, describing location in a distribution. I believe we've already finished page 1 of the notes where we talked about percentiles and the cumulative relative frequency graph, also known as ogive. So let's go to page 2. On page 2, we are given the ogive that we created manually on page 1, and we were asked 2 questions about it. At what percentile is California with a median household income of $57,445? Well, let's take a look at our graph. Where does $57,445 show up? Right here. If I extend that point up vertically till I hit the ogive, and then I go from that point on the ogive horizontally, I find that I'm about 80%. Okay? So I would say this. Cali is about 80th percentile of median household income. But wait, there's more. Okay, we can also use the ogive another way. We can start from the vertical axis, the cumulative relative frequency. So we're asked in part B to estimate and interpret the first quartile of this distribution. So let's do that. The first quartile is the 25th percentile. That happens right there. So I'm going to take that line horizontally across till I hit the ogive. Then I'm going to drop down vertically till I hit the x-axis. So it's a little more than $45,000 median household income. We'll call it 46. Estimate and interpret. The Q1 value is about 46, period. This represents the 25th percentile. Otherwise known as there are 25% of the states that are below that value. That's our definition of percentile, always below. So this would be nice if I could color code that, the graph. Now look, this is modern technology in a way you've never seen before. Am I right, Sam Gray? Okay, folks, we got 2 big definitions now to talk about location in a distribution. They are... Why are you laughing? I know. Go. Standardizing is the process of converting an observation from original units to standard deviation units. A couple days ago, I asked you all what your height was in inches. And we wrote those values on the board. And I said, and I picked one student. And I said, how would you describe your location in the distribution? And his explanation was something like less than average. Because he was short. And then we talked about how else could we describe that person's location in the distribution. And I asked the question, and you may not remember it from 2 days ago, I asked the question, could we describe his position in the distribution relative to the mean by using standard deviation units instead of inches? Could we convert it to his particular height to a standard deviation? Absolutely we could. Okay, and here's how we're going to do that. We're going to talk about something called the standardized score. It is also known as a z-score. It's more fun to say z-score than standardized score, so that's how I'll say it the rest of the year. Calculating a z-score is standardizing an observation. Okay? If x is an observation from a distribution that has a known mean and standard deviation, the standardized score for x is as follows. X minus x bar all divided by s sub x. In words, that's x minus the mean, all divided by the standard deviation. So what I want you to do now is take a look at the next example. I give you some data from baseball year 2012 and ask you to calculate a z-score for 2 different teams and then describe what it means. Go. Okay, let's talk about the Yankees. Z-score of the Yankees is observation of 95 wins minus the mean, which is 81, all divided by the standard deviation, which is 11.9. And do me a favor, somebody tell me what that value is. I heard 1.176. Okay, 1.176. What does that value represent? Does that mean the New York Yankees are good or bad? Statistically, that's pretty good. They're a full standard deviation above the mean. They're more than a full standard deviation above the mean. Okay? So the Yankees win total was 1.176 standard deviations above the mean. Now let's talk about the Mets. Same city, different team. The z-score of the Mets is going to be the win total, 74, minus the mean of 81, all divided by the standard deviation of 11.9. That z-score, you should have got a value of negative 0.588. In context, what does that mean? They're below average, right? Their win total was less than the mean by a little more than half a standard deviation. So I'd say something like the Mets win total was 0.588 standard deviations below the mean. So let's quickly talk about something here. We'll go back to the Yankees. This was positive 1.176, and that positive value represents above the mean. And then with the Mets, the z-score was negative, which represents below the mean. So it tells us not only how far they were from the mean, but what direction, above or below, based on the positive or negative sign. Let's take a look now at some home run kings throughout the history of baseball. A lot of text to read there, so I'm going to give you a chance to read that, think about it, do what is asked of you, and then be prepared to answer the final question, which was, which player had the most outstanding performance relative to his peers? Babe Ruth, Roger Maris, Mark McGwire, or Barry Bonds? Go. Folks, one thing I want to comment about this example, each of these years is a different distribution. So we have mean and standard deviation for those different distributions. The z-score for Babe Ruth is 60 minus 7.2, all divided by 9.7. That value is 5.443. Let's go ahead and grip it and rip it through the rest of these. We have 4 z-scores to compare. We have one that's over 5. The rest are between 3 and 4. These two right here, really close to 4. Those two are comparable. So if I was to answer the question, whose season was better, Mark McGwire or Barry Bonds, I'd say, well, Barry Bonds was a little bit better, but it was really, really comparable. Those two observations in those different distributions are comparable. Shortly in the course, in a couple weeks, we're going to be able to take these z-scores and make some bigger statements about, like, what percentile does that represent? And then that's even easier for us to make judgments about what this performance is. And what we'll learn when we get to that point in the course is that these z-scores are amazing. These are really, really high to the right-hand side of the distribution, okay? But this one here, Babe Ruth, that's unreal, okay? To have a z-score that is 5.4 standard deviations above the mean is one-of-a-kind type performance, okay? So what you might want to say here is something as follows. Babe Ruth performance, comma, at 5.4 standard deviations above the mean is the best among these players, comma, but they're all really freaking good. Okay, all of those are amazing z-scores, but clearly Babe Ruth is the best of the best. Questions?